Welcome friends, I am Tanmay and welcome you all in my channel Chemistry and History of Molecules. Today I shall discuss about Claisen Ester Condensation. Previously I have uploaded video about aldol condensation by Newton's trajectory. I suggest you first watch that video because aldol is the basic reaction and such type of reactions are the extension of this reaction. Okay. So today we are going to discuss mainly about the basic of aldol condensation. And this lecture will cover some point, for example basic concept and comparison with aldol. As I told previously with aldol, you can understand why. Second, I will explain about mechanism. After that I will explain what is the driving force for this reaction. Then I will explain about the choice of base and alpha hydrogen. And finally pKa value of all the product in the equilibrium. Okay, so let's start. So first of all, let's discuss about the basic. Basic is reaction of an ester with a alpha haloester to produce a final 1,3-dicarbonyl, 1,3-diketone. Why I am saying 1,3-dicarbonyl? If I consider 1, that is 2, that is 3. So in this way 1,3-dicarbonyl compound and ethanol is produced. So in short, if we write what's happening, this ethanol is from this side one ethoxide and this side one proton is removed and to produce the final. So these and these are getting attached. Okay. So the question how this is happening means mechanism and comparison with aldol. In aldol we have observed that a carbonyl group in presence of base or acid produces beta hydroxy carbonyl. Means this you can say like that, beta hydroxy carbonyl in presence of acid or base. We will consider the base mediated part. Okay. So what happens? This reaction proceeds through a enolate. Enolate means this. After abstraction of enolate, this produces the proton. This produces enolate, which is resonance stabilized, and in this way, it produces a nucleophile. And that nucleophile attack another molecule of carbonyl, which is electrophilic center, produces the final beta hydroxy alcohol. So these basic concept will be utilized here. Here what happens? This ester molecule after deprotonation by a base like sodium ethoxide produces this CH2 minus O18. This is an enolate. So this is resonance stabilized using this carbonyl group. So this is CH2 O minus O18. So right now this is more nucleophilic, this double bond is compared to this. So charge density is both on carbon and oxygen. So we can consider it as amphiphilic, but reaction happens through this carbon center because this is more nucleophilic, softer in nature. Okay, like aldol condensation. So this attacks to another. This attacks to this carbon group. So what happens? It comes back and it goes and produces a tetrahedral intermediate. What do I mean? CH3O minus OET CH2 C double bond O OET. So what happens? This pushes the electron and it leaves under alkaline condition. So what is produced here? CH3 CO CH2 COOET. Okay, this is and OET minus. So this is produced. So we have observed how this is produced. Okay, so the question is what is the driving force? Okay, for example, if we check this step produces from this ester to this ester enolate. Along with this, it produces a ethanol molecule. Okay, this ethanol. So, if you can see the pKa of this ethyl acetate is 24. This is the acid right now, and it produced this. Its pKa is around 17.5. So we can see from weak acid to a strong acid is produced. Okay, so this is not that much favorable equilibrium. So it is expected that majority of this equilibrium will remain in backside, means very small amount of this carbon ion means enolate will be present in the reaction medium. First step. Second step, what is happening? This is acting as a nucleophile and attacking this center. This nucleophilic attack is also a reversible reaction. Fine. So this reversible is producing, since concentration of this is less, so it is expected generally the conversion of this 1,3 dicarbonyl is also less, but reaction becomes this direction because of one important step, and that is the driving force, and that step is the abstraction of this proton. Question: why? Because you can see, if this proton is abstracted, because in medium there is sodium ethoxide in ethanol extra present, so what happened? It produces this minus OET. Okay, so this is more stable. Because you can see its pK is around 11, because this negative charge is stabilized by the conjugation of both this or this. So in this way, this negative charge present. This is the driving force of the reaction. I repeat, this step is the driving force of the reaction. So whatever is telling initially that alpha hydrogen is needed is true, but not one alpha hydrogen. Generally, I repeat, generally, special cases are there. Generally, 2 alpha hydrogen are required. First for this, second for this. Now, one trick could be asked. For example, if one equivalent of ethoxide is used, one equivalent, so what will be the consequence? So, if for this reaction, if one equivalent is base is used, then half of this will produce. It does, but it is not true that this will go and produce one equivalent. Means from 2 equivalent, if 2 equivalent ester are taken and 1 equivalent base is taken, these will not produce 1 equivalent. It will produce 0.5 equivalent. Because first step is difficult, I agree, but the second step is more faster. So whatever product will be produced, that will consume the base instantly, and that is that since the driving force, so it will be, so 0.5 equivalent this base will be produced. Okay, so this is the main thing. Now you may have a question, why? Because I am considering a enolate. This enolate as a base, or you can say actually enolate is a nucleophile here. So here a carbon ion. This is also a carbon ion. Why this is attacking, not this? First of all, the charge density on this carbon is more. Second point is that this is more bulkier compared to this. So reaction will proceed through this, not through this. So don't get confused. Second, after that what happened? This H3O plus means dilute acid is needed to get the final product. So since it is not written here, so you should write the product here. You must stop here. Not the final product you should write. Okay, so here first one this and second one H3O plus is essential. I guess you have understood what? Okay, now the question we have discussed about driving force. What is the choice of base? Here throughout the process you have understood base has a unique role. What do I say? I told you alpha hydrogen is essential for Claisen, it's true, but 2 equivalent of 2 number of alpha hydrogen needed to get the completion according to this. But question, why if there is 1 equivalent alpha hydrogen is present, for example, you can consider the example of this reagent. So OET. So this satisfied all the factors. This satisfies all the factors of this Claisen condensation, but here 1 equivalent hydrogen is present. So question, will it participate into the reaction? Actually possible. It will participate in the reaction if some special cases are applied. Special cases, what do I mean? For example, we are using a base using ethyl acid at a pK 24, and the problem is that the ethoxide means ethanol's pK. Okay, so if we can use stronger base whose pKa means the conjugated acid's pKa is higher than this, means weaker acid than this, then it will happen. For example, if we take LDA, LDA means lithium diisopropyl amine. This is diisopropyl, this is minus lithium plus. So if we take this, it will abstract irreversibly, means, or more precisely we will say equilibrium will be in the carbon ion side. So in this way it will produce this carbon ion, and this carbon ion will attack to another of this molecule in a better way, or so another ester molecule, so this reaction will proceed and this situation will not be, because after reaction, if we consider the product is, if we consider the reaction, the product is this. Okay, so here one thing you must keep it in mind. Here also you need to use two equivalent of base. Why? Because first of all, first unit of base will consider abstract this, and second unit of base will abstract this. Actually, you can see as like previous, there is no active methylene proton, means I am talking about this carbon, but this is, and according to the acidic strength, this is also capable. So here also we need two equivalent of base. So this is. So I guess you have understood the choice of base. Similarly, stronger base like KHMDS means what? KHMDS or diphenyl carbonyl, such type of base. And according to this is a criteria of base. Base must be non-nucleophilic. Why? That must be non-nucleophilic. Why I am saying this? Because if base is nucleophilic, then base can attack the center and hydrolyze the ester and produce a cross product, which is not expected. So in order to avoid that chance, the base must be non-nucleophilic in nature. Okay? Okay. So we have also discussed about the alpha hydrogenation and choice of base. And finally, we have previously discussed about all the pKa values of this. So what is the utility of this? To get 1,3-dicarbonyl compound. Let's discuss another point which I forgot to mention, that is the role of solvent or choice of solvent. Okay, it matters. But for example, we are doing reaction sodium ethoxide in ethanol. Okay, and here ethanol is also produced, and the pKa of ethanol is one of the biggest problem, as the pKa is 17.5. For that reason, we need to use extra base. I know this is the problem. This problem could be avoided. For example, instead of ethanol, because from a weak acid, means pKa 24 to pKa 17, weak to strong acid is prepared, that step could be make irreversible. How? For example, if we consume the produced ethanol, means eliminate from the reaction mixture, then the problem will not be there, that strong acid to weak acid, that because the weak acid to strong acid, because the strong acid is consumed, so equilibrium will be faster. So for that purpose, one thing could be used, instead of sodium ethoxide ethanol, sodium in ethanol, first choice could be used, because it will instantly produce sodium ethoxide. Okay, it's sodium plus ethanol. If we do the reaction, it will produce NaOET plus hydrogen gas. But you may argue that okay, there is some risk using this. Okay, fine, I agree. For that purpose, what could be done? For that purpose, it could be done, we can take another third type solvent, for example, that is ether. Okay, and another one important thing, alcohol, it is very difficult to get anhydrous alcohol. So what we are trying to solve the problem of ethanol, if in the medium there is water that is more acidic, so it's a bigger problem, and it is very difficult to get anhydrous methanol. For that purpose, ether is a better choice, because it is very easy to get anhydrous ether by reacting ether with sodium, and in this way water is consumed and ether is distilled off. So we can take ether as a solvent, and along with that we can take sodium metal. Sodium ether don't react. That's why the ether this means anhydrous ether preparation procedure is based on sodium plus ether in benzophenol. Okay, that's different. So, and one drop of ethanol. What happened? One drop of ethanol. So you can see one thing. First, this one drop of ethanol will react and produce sodium ethoxide in this way. Fine, gone. It will act as a base to produce the ethanol again. that ethanol will go this cycle again. So in this way, actually the weak acid problem we are solving using this sodium ethoxide, 1 drop of ethanol, and here actually the base is this ethoxide. Actually the sodium ethoxide is acting as a base, but this reaction we are taking in our right one step further. So this is finally the end of the basic discussion about Claisen ester condensation. In subsequent video, I shall discuss about cross Claisen. That is more important to have a wide versatile substrate preparation. So this is the end of this video. Thanks for listening my video. If you like my teaching, please give a like, share this video among your friends such that many people could be benefited from my effort, and subscribe my channel Chemistry and History of Molecule, and please press the bell icon to get the notification of every single video I upload. Till now, stay happy, stay blessed. See you in my next video.